All right, so we got 40 seconds to go until day 3 opens up. I am ready to spring on this problem input. Let's see, day 3. So last year, day 3 was the wire, the intersecting wires problem. So I'm hoping we get maybe something like that. I think that would be kind of cool, like a grid-based problem. Manhattan distance, something like that. But we shall see. 2, 1. All right, here we go. Ooh, don't tell me it fell over again. This looks like a grid problem. For the slope right 3, down 1. Wait, so we're starting, need to reach the bottom, below the bottommost row. Right 3, down 1. I don't get how you get 7 from this. Oh, where it intersects a tree. Okay, well, fair enough. So how long is this? We're dealing with 323 rows. So that's gonna be iota 323. It's actually going to be easier if I do IO0. Iota 323 3 times gives us this. Iota 323 like so. For each one of these indices, is that right? Right 3, down 1. So for each one of these indices, and what's the max? 966. So we basically need to do like P is P mix P enclose 3 row join disclose and row P. Wait, what? Row mix P. This should have been substantially larger. And indeed it is. 279, still not large enough. So let's do another one. Wait, why can't I? What was our largest? 966. Oh, this is hacky. But whatever. All right, great. And then uh, for each p index jot, uh, tree equals 164. 577, all right. Multiplied together. Okay, sure. Okay, so what do we got? We got 1, 1. These are actually going to be reversed. So 1, 1, 1, 3, 1, 5, 1, 7. 2, 1. And I want to 5, 2 row this. Yep, and then split it. Yeah, I know. For each for each iota 323 times W. Wow. Really? I don't think. Oh, yeah, duh. Huh. Uh, rank 1. No. It's rank 1, 0. Right? To get something like this. Split it for each one p. Well, okay, just yeah, that's fine. Syntax error. What's the link? What's the shape of p? And then for this one, if I enlist all this stuff, what's the maximum? Okay, so it will fit. So for each p jot like this, right? Really? Ooh, right. That last one is annoying. Minimum 323. I don't know, 5e6, whatever. Rank 1. Crap. rank 1, 323, greater than or equals the first element. And we'll call this T, and we can use that. This has to be first to select on T. Right? Actually, give me that last one. What are we looking at there? 322, whatever. All right, great. And now we can split this for each index job P, right? Equals sum multiply reduce. You get this thing. No leadership. Too bad. Still not bad though. Okay. Well. Oh, geez. Oh, hey. I didn't know you guys were in the chat. All right. What position on the leaderboard? Dude, people are insanely quick. So that one was for day 3. I did all right actually. I got rank 577, but then for rank 2 it's 1011, and uh, this basically means that there were like 1,011 people that solved part 2 before I did. Anyway, hopefully, yeah. How's everyone doing? This is gonna be tricky to parse actually, so I think this is just inget in 3.text 1 take, and then it's just mix, right? And that's P. I think that gives us the grid. Yep. But then we have this thing where we essentially need to, so if we go back and we look at the problem, we have this thing where we go right 7 down 1. And if I look at the shape of P right now, it's 323, 31, right? So this thing needs to be replicated at least 7 times 323, 31 divide at least 73 times. So let's do that. So this is going to be length. Length P. 7. Yeah, 7 times, and then we'll divide by row P last element. And that's a ceiling. Right. 73. And then this should be row enclose P, catenate take, And then this will be like PT, I guess. So now if we look at the shape of PT, we have this 2263, which should, yep, it'll cover the final index. Okay, so now basically have this function where we're taking a list of elements of indices, and we're going to say w index job p for each. This thing equals sum, right? And this is PT actually. And for the first one, that's just iota 323. 1, 3, rank 1, multiply, split. Mismatched. Right, this is 1, 0, actually. 164. Right, which is the answer here. So this is part 1. And so I'm going to call this function f. And then we're going to run f on this. And then we have this thing, which is like 13571 to, what is this? I can start up an OnlyFans account. If I can get that money rolling in. This is basically like a base 7 decode. So if I do like iota, if I do like iota 5 2 times, I get the numbers from 0 to 8. And then if I do a 7 7, I always get these mixed up. Decode, encode. Close. 1 plus. Yeah, there we go. Ooh, but I want that to be a 7. So we'll do it the other way. We'll say at 2, at 1 actually, 1 job plus. Yeah, check that out. Oh no, it's 1 plus the whole thing. Write 1 down 2? Well, whatever. We'll just manually do it for now. So this is 1 1. This has to be in reverse because we're in row major order. So 1 3, 1 5, 7, 1, 2 1. For each one of these, we're doing iota 323 W times rank 1. And then we have to do this kind of filtering. How'd this, oh, 1.7. Yeah, so we can call this like T right tech reduce length P is greater than or equal to, use that to filter on T. Split, and I think for each one of these we can call F on it. Oh, didn't I define F? Right, and then multiply reduce, which gives part 2. In terms of length, so for PT at least, oh geez. If I do all this, and I take length P cons P row transpose. The rightmost element of row P times, right. That is not an improvement in the slightest, so I guess never mind. This one I think can be shortened if we did, like if we pulled this logic, and we just put it like here, for instance. Now, we can just say F 1.3. And now we can just say F for each one of these. And I'm like reasonably sure that'll work. Yeah, it does. then if I can just figure out this base 7 thing. So what did I have up here? I mean, this won't work if I do 8-8, right? Yeah, I guess it does. All right. Get out of here. All right. Yeah, I think I'm pretty happy with it. One other thing, if I do this in IO1, does it still work? No, it sure doesn't, so it has to be IO0. All right, cool. I'm gonna ship it. Well, thanks for tuning in, everyone. Thanks for the raid. um, yeah, I'll see you tomorrow.